Just wanted to share with you all, I've had a major problem of working with Zoom and Google Meet. Nothing wrong with them. I just could not record the lesson. So it's my third time doing this, and hopefully this is going to work. I'm using Microsoft Teams. So just to share with you, let's talk about our next unit. Unit 3 is related to Chapter 5. If you could turn to your workbook, give me a second. Hopefully you can see this PDF on your screen. This is our unit, Chapter 5. And we are going to start off with the first thing called multiplying two binomials. That's for today's lesson. So, hope this will work. Just give me a second. This should be the same package for you. And I was going to give you a background information about what are quadratics, but I'm kind of upset on how long it took me to do. So please enjoy. Hopefully I don't make any mistakes. At any time, please feel free to pause the video or increase the speed, lower the speed, and I'm sure you'll be fine. Let's get started. So let's take a look at the first question. And you know what? I'm going to get rid of my face, if that's okay, so that you can focus on the camera. I mean, the worksheet. How do I do that? There you go. So hopefully you can see this PDF. And notice what we're going to be doing is multiplying two binomials. A binomial is two terms, and a term is separated by plus signs or minus signs. The general form kind of looks like this, and I'm going to write it up top of the sheet of what's going to happen. You've never done this before, but it is analogous to distributive property. So in my example, or the general example, a plus b times c plus d, we're going to multiply those out. And we should get this as an answer. AC plus AD plus CB plus BD. Now, some of you might be concerned on how you write the numbers, but that's okay. So multiplying or expanding, it is also known as clearing brackets. You could also think of it as this technique called foiling. And as you can see from the handout or from the workbook, excuse me. I wish I could pause. Can I pause? I cannot. Oh, well. As you can see from the questions that we're going to be doing, we're going to do a plus 2 times a plus 4. So FOIL stands for the first term, then we do the outside terms, then we do the inside terms, and then we do the last terms. Let me just zoom in a bit closer to the first example, and let's see if you can follow along. What you're going to be doing is always multiply, multiply, multiplication. So I'm going to emphasize the first one for the F, which is the first term, and I'll show this in red. And we're going to multiply the A times the A. A times A, it's not 2A, but rather A squared. To recall a grade 9 concept, for variables that have the same basis and multiplying, we can actually add their exponents. So let's take a look at this question one more time. The first A has an exponent of 1. The second A has an exponent of 1. 1 plus 1, 2. Now, if you've been hearing me, yes, we are multiplying. But that is the fast way of using the exponent rules. This stands for the first terms. The A's are the first terms. First terms. We keep on going. I'll use orange. What we're going to do next is we're going to multiply the outside terms. Now, the outside terms are actually the A in the first bracket and the 4, or the positive 4, in the other one. A times 4, That's positive 4a. And hopefully it's coming out. It might not be, but that's okay. Our third example that we're going to keep on going, I'll use green. The green represents the inside terms. Oops, and I forgot to put the other color for orange. Let's put that there. Much better. Green term. And that stands for the inside terms. What are the inside terms of this question? Well, it's that positive 2 and that a. So when we multiply positive 2 times a is positive 2a. Finally, the last terms. The last terms, and we'll use this nice pink, is the positive 2 and that positive 4. Now, you don't have to show me with these arrows, but that might help you to figure out what we're multiplying. 2 times 4, or positive 2 times positive 4, is positive 8. As you can see, there are 4 terms, but we're not finished. This is why we had to practice for the grade 9 review how to collect like terms. So let's take a look at this answer, which is a polynomial. We have a squared plus 4a plus 2a plus 8. There are 2 like terms, and I think you understand what I'm trying to do. The 2 middle terms, which we did the o and the I, are these 2 terms. So 4 apples plus 2 apples, the answer is 6 apples. And this is our trinomial. So we have a squared plus 6a plus 8 is our expanded version of a plus 2 times a plus 4. One more time, this is known as clearing brackets, or a lot of kids know it as foiling. Let's move on to the next example. Question B, we're going to do m times m, which is the first term, m squared, m times positive 5, positive 5m, negative 4 times m, negative 4m, and negative 4 times positive 5, refresher for a lot of you, and negative times a positive is a negative. Again, if you have to pause the video to make sure you're doing this right, please go ahead. Also, I'm just trying to show you the most efficient way that a lot of students are taught this foiling method. It actually does not matter, but as you can tell, it groups the terms in descending order. It usually does. So what do we have? Pause the video if you want to try it yourself. There are a couple like terms. Positive 5m, take away 4m. It's like saying 5 money, take away 4 money. How much money do we have? We only have 1 money. And you can still write the 1 as the leading coefficient, but that's okay. We're going to try question C now. I'll just move over. My dog is barking in the background. And I think this is supposed to be an X. So please check that. Let's try to do this quickly. Notice this one's a lot harder. So take your time. And this time I'm going to focus on the colors that we used. So for the first term, this time we're going to do 3x times 2x. Now 3x times 2x, multiply the coefficients. So 3 times 2 is 6. And x times x, that is x squared. Keep on going with this pattern. Orange. We're going to do the 3x times that negative 6. Try to beat me to it. You get negative 18x. Going to the inside terms, negative 4 times 2x, that is negative 8x. And then the last term, negative 4 times negative 6, positive 24. Notice this is why we had to make sure you understood how to deal with those integers. And don't be embarrassed if you need to use your calculator. Collecting like terms, I think everyone agrees. The 6x squared and the 24, they're fine. But negative 18x minus 8x is negative 26x. And again, our answer when we expand, there should be no brackets, right? We should probably have this thing as a trinomial. And that's what a lot of you are noticing. And you should be able to solve that. Pause the video if you need to check over your work for A, B, and C. Let's keep on going then. Question D. What we have is x times x squared, x times positive 6, positive 6x. Let me just fix that so it's a bit cleaner. Much better. Negative 6 times x, negative 6x. And negative 6 times positive 6, negative 36. Now this one should be a little sus. And if you've been paying attention, I said to you that most of the time we get a trinomial. But notice what we have. We have positive 6x and negative 6x. Guess what? That gets canceled. So what we get is x squared minus 36. Technically, you could write this as positive 0x, but that's a little silly. So let's see if you want to pause the video. Try to do this one without using FOIL. Now, some of you are saying, what? Foiling is the technique that we're showing you? I'm going to give you the answer. The answer is m squared minus 25. So what do you notice about these answers? Well, it seems like in our examples A, B, and C, we had trinomials, but for D and E, we got binomials. That's pretty good. I think you also notice that when we did the O and the I of foiling, the outside and the inside, those got canceled. So this pattern, which is actually an important pattern, this is called a difference of squares. The word difference, you already know because I taught you. The word's difference means to subtract or minus, and that's this symbol. And squares, these represent the perfect numbers. What's a perfect number? 25 is a perfect number. And the reason why you know that is because it's made up of 5 times 5. Notice the example D, that last term is 36, and it's made up of 6 times 6. So hence, this is called the difference of squares. Difference of squares! And this is a very useful pattern. I will give you the formula right now, but we'll practice it later to make sure everyone's okay. This pattern happens to be as follows. A plus B times A minus B is equal to, when you FOIL this, you get A squared minus B squared. It is a difference of squares. Pause the video if you have to. Last two. So we have question F and question G. Let's take a look at it. And if you've been noticing, I don't say the brackets in this, right? So for question F, the way that you say this question, expand y plus 4 times y plus 4. So we'll do the foiling for this one. Pause the video if you want to do it yourself. But I'm just going to go ahead and do it. The first term, y times y squared. Y times 4, positive 4y. 4 times y, positive 4y. And 4 times 4 is 16. This one, for some reason, a lot of students find, what's the big dealio? If I know how to FOIL, which is a good practice, and you can always FOIL. This actually has a pattern that hopefully you'll recognize. 4y plus 4y. First of all, notice that these two terms are the same. 4y and 4y. Not 3y, it's not 7y, it's not 7x, not 4j, it's nothing. But what happens is that we get 8y. So this one, unfortunately, is not like the difference of squares, which we just talked about. Let's see if you can actually see a pattern. Now this one's tough. So when we get to question G, feel free to pause the video, try to do question G yourself, what we're going to do is p minus 7 times p minus 7. Here is the answer. P squared minus 14p positive 49. So what do you notice about F and G? Hopefully this time you can talk to your classmates or maybe look in the textbook in section 5.2. What you should notice about this is that, first of all, we have a trinomial. And if you really think about it, this question, p minus 7 times p minus 7, it can be written as this: p minus 7 all squared. P minus 7 all squared is the more condensed version, and a lot of students find this easier to use. Now, I just want to give you some background why we're doing all this. We want to get your algebra skills down pat, and that is why expanding is so vital. So if you need to brush up on your multiplication and or you need a calculator, please be my guest. But we're always multiplying first, and then we're simply adding or subtracting the inside terms. For pattern-wise, for question G, though, what I'm trying to share with you is that this pattern is called a perfect square. So this one's different from what you just saw above. A perfect square literally is this formula, and I'm trying to see if you can actually comprehend it. What a lot of students make a mistake is they think it's a squared plus b squared. And that's a big no-no. This is not a perfect square. And I'll make sure it's no, using this nice lilac. No. Do not make that mistake, folks. But what you should notice is that a plus b all squared is literally the squaring of the first term, the squaring of the last term, and notice it's always positive. And notice what I'm going to write in the middle. The middle term is 2 times a times b. Let's take a look at this one more time. The p is our a. The negative 7 is our b. So watch what I'm going to do. If I understand this question, writing it in this color, and I'll try to do it again. P minus 7 all squared, and that is our a term, and that is our b term. Pause the video if you need some help. But let's square that a term. Squaring that a term, that p value, is p squared. Square that negative 7. A lot of you noticed on today's or yesterday's test, you were understanding that negative 7 all squared is positive 49. So that is the first term and the last term. So what is in the middle? So I would like you to try, but you don't have to. If you still want to use FOIL, that's okay. But what you'll notice, if you take a times b, or in this case, p times negative 7, and that's what literally this means, a times b, and then double, you should be okay. So negative 7 times p, go slow if you have to, negative 7p, and then put a plus sign here because there's a plus sign there, 2 times this. Let me just move this down. We get p squared plus, minus p squared minus 14p plus 49. Our last one, and I'm just going to do this example, and hopefully you can work on the other questions. I'm going to just show you my way of doing this question. Sorry for the coughing, folks. So I recommend for this question, 2 times x plus 3 times x plus 5, you FOIL first. So if you need some help, I'll dry them out. And you're allowed to do this because multiplication is what's called commutative. So x times x, x squared, x times 5, 5x, 3 times x, 3x, and then 3 times 15. Collect the like terms, x squared plus 8x plus 15. And notice, because I think you're very successful, we're just going to use distributive property. Remember, expanding or distributive property is simply clearing the brackets. So what do we get? 2 times 1 is 2x squared. 2 times 8 is positive 16x. And then 2 times 15, that is positive 30. Notice there's no brackets. And this is called the expanded form. The second method we'll talk about in class. But I want to thank you, and hopefully the video helped you out. You can try to do the other method 1. You can also work on the questions that I just posted on our Brightspace. And you can do the optional sheet. Let me just turn my camera back on. So I wanted to thank you. Hopefully that made sense. Thank you for watching. And if you have any questions, please let me know on Wednesday. Wednesday is a late start. Have a nice day, everybody.